In today's video, we're going to be going through this whole entire exam paper. I would really encourage you to have one piece of paper next to you for any formulas that you weren't too sure of that come up, or any parts that you weren't too confident with and then you learn, or something that you forgot and then you remembered as we go through the video, okay? So the questions that we're going to do are obviously going to be, some of them are going to be straightforward. Some of them I'm going to be using as an opportunity for you to recap maybe tree diagrams really quickly, or recap recurring decimals really quickly. So use this as a revision tool for you to go over the majority of the topics. Now, let's go to question 1. So the question says to expand and simplify. They wouldn't say simplify for no reason. So just remember, there's two things that we're going to do. We're going to expand it and then we're going to simplify. Whenever you see brackets, brackets always mean multiply. So I'm going to expand it by multiplying across. So 3 times 2y is 6y. 3 times negative 5 is negative 15. Now we're going to do the same for the second set of brackets. So 7 times y and 7 times 2. 7 times y is 7y, and they're both positive, so I'm going to put a positive 7y there. 7 times 2 is 14, and again it's a positive 14, so I'm going to write plus 4. So I've expanded. Now I need to simplify. So I'm going to put the y's together and the numbers together. Now the invisible sign before the 6 is a plus, and it's really important that I'm looking at the sign before it to tell me if I'm adding or subtracting. So here I've got 6y plus 7y, which is 13y. Now let's look at the numbers. I've got negative 15 plus 14, which is negative 1. So my final answer is 13y minus 1. Now that negative 15 changes a lot for me. So do you see why the negative 15 is important? Because if I did 15 plus 14 straight away, I would have got 29, which is a wrong answer. Now part B, it says factorize. Whenever I see the word factorize, I know there's going to be brackets. So factorize fully, I'm going to open up my brackets. So factorizing, a tip is you're going to be putting brackets. And on the outside, I write down anything that's common. So if I look at the 6 and 15, what number is common between 6 and 15? It's 3. And if I look at the letters x and x, x is common between both of them. So what do I times 3 by to get 6? That's 2. I've got an x here, but I need another x, so I need to put 2x. Now, what do I multiply 3x by to get 15x? 3 times 5 is 15, and there's already an x. So plus 5. So 3x brackets 2x plus 5. Now, make G the subject of the formula. Make G the subject. If they say make something the subject of the formula, they want you to get it on its own. So basically, they want you to have G on its own. If I look at this equation, let's rewrite it over here so I've got a bit of space. F equals 3G plus 11. There are two sides to the equation. There's the right side and there's the left side. Okay, you want to bring everything over to the opposite side, and you want to end up with G on its own. And the way to get rid of stuff is to do the inverse. So I want to get G on its own. What are the two things that I need to get rid of? I need to get rid of the plus 11, and I need to get rid of the times 3. So which one do I get rid of first? The one that's furthest away from G is the one that I start off with first. So the opposite of plus 11 is negative 11, and I do that to both sides. So these two cancel out. 11 minus 11 is 0, and I end up with F minus 11 equals 3G. Now I still want to get G on its own, so I need to get rid of this times 3. The opposite or the inverse of times 3 is divide by 3. So I'm going to divide by 3 here, divide by 3 here. These two will cancel out, and I end up with F minus 11 over 3 equals G. Is G on its own now? Yes. So I'm done. Let's go into the next question. Question 2. With worded problems like this, either they're going to give you information or you're going to do something with that information. So Karen is organizing a party for a charity. She spends £100 on food, 120 on a hall, 80 pounds on a DJ. So in total, what can I do? That she spends £100 plus 120 plus 80. So she spends £300. Okay, so she sells 54 tickets. Each ticket costs £7.50. So she sold 54 tickets times £7.50, which gives you £405. So far, I've just used information and written down whatever I could with it. Now let's read what the question actually wants. It says, work out the percentage profit. The percentage profit, there's a formula for that. So whenever you see this is a key thing to highlight. So the percentage profit is your profit that you made, or the change, over your original amount times 100. So this is the percentage profit. And I'll also write change, so how much she made. So the profit over here, she sold for £405, but she spent 300. So the profit she makes is the difference of both of them. Over the original amount that she spent is 300 times 100. If you put that on your calculator, 35%. So she made 35% income. Okay, question 5. Andrew invests £4,500 in a savings account for 2 years. I'm just going to highlight things that I need. The account pays compound interest. This is, again, really important. Compound interest is a formula for that. It would look something like this. A equals P, brackets 1, plus the rate, R, over 100, all to the power of N, which is the number of years. A over here, this is your final amount. P is the principal, which is basically the original amount. So let's write original. R is your rate, and the rate here of 3.4% is out of 100. That's why R is divided by 100. And then N at the top, that is your number of years. No interest, you've got a certain amount of money, which is a 4,500. He puts it in the bank or in a savings account, and after 2 years, that money increases. That's the interest that's put onto it. Okay, so how much has he got in his savings account at the end of the year? Let's put that information in. So A equals the original amount, which is 4,500, brackets 1 plus the rate. What is my rate? 3.4%. 3.4 over 100, all to the power of N, which is the number of years, which is 2. Now, if we put it on the calculator, we get 4,811 point. Now, because it's money, we leave it to 2 decimal places. So this is my final amount. Now, when you answer these questions, try to see if it makes sense. I put 4,500 in the bank. It has to go up. I've got 4,811. It seems like it's correct. Okay, that's one way to also check. So it says, calculate how much Andrew has in the savings account. So how much he has in the savings account at the end of the 2 years, which is 4,811.20. Now, something to note, which I'm going to put on the side, because obviously you'll get different questions, and you're not doing this paper just for this, you're doing it to actually learn. This last line, if they were to say money, how much more money did Andrew make at the end of the 2 years, would my final answer be 4,811.20? No, because they don't want to know the total amount. They just want to know how much more money he got on top of it. Or if they said, how much interest did he get? So to find the answer to this, we're going to do 4,811.20 minus 4,500. And if you put it on your calculator, he made £311.20 more. Okay, this is just a side note, so that when you're doing these questions, look at this last thing just to make sure that you are writing the final answer as they want it. Okay, question, solve an equation. Just like where it says make something the subject, you basically want to get x on its own. Okay, so when you're solving the equation, you want to get x to be on its own. Now notice we've got x's and numbers on one side before the equal sign. We've got x's and numbers on the other side. So what we want to do is we want to bring them over to one side. Okay, we're doing the inverse. So let's bring this minus x over to that side, so it becomes a plus x. And let's bring this minus 14 to this side, and it becomes plus 14. So I've got 5x already there, plus this x. So when I move the minus x, it becomes plus x, equals, and I've got 52 already there. When I move the minus 14 there, it becomes plus 14. Now let's clean this up. 5x plus 1x is 6x. 52 plus 16 is 66. The opposite of times 6 is divide by 6. I'm going to divide both sides by 6. These two cancel out, so I end up with x equals 11. And that is my final answer. Now, how could you check your answer? Let's put it here on the side, because obviously you want to know how to check your answer. That's the difference between getting marks and losing marks. So to check my answer, I put 11 in. So I've got 5x minus 14 equals 52 minus x. So I'm going to put the 11 in, which means that this side should equal to that side. If I put 5 times 11 minus this side gives me 41. And here, if I put 11 instead of x, so 52 minus 11, it gives me 41. 41 is equal to 41, which means it is correct. This question is the best question to look at all the different kinds of ratios. Chris, Debbie, and Errol share some money in the ratio of 3 to 42. I'm just going to write it here because I want more space. So it's 2. So this is Chris's amount, this is Debbie's, and this is Errol's. Okay, this is how many parts each person gets. Now, some students, whenever they see their ratio, they see a number, they go into sharing straight away, share it. But look here, it doesn't say that they're sharing it. It says that Debbie gets £120. So there was a certain amount of money that was shared between all of them. And after they shared it, Debbie ended up with £120. So to find out how much one part is, I'm going to do 120 divided by 4, and that will tell me how much each part was worth. So 120 divided by 4, that means each part was £30, and that's why they multiplied that. Each part was £30. So Chris got 3 times 30. So Chris ended up with £90. Now Errol also times 30. Errol ended up with £60. So far I haven't read the rest of the question, but I read this and that, and I did everything that I could do with it. Now let's look at the next part. So the next part of the question, they say that Chris then gives some of his share to Debbie. Very nice of him. And some of his share to Errol. Very kind. The money that Chris, Debbie, and Errol each have is now in the ratio of 2 to 5 to 3. So let's do that. This is the new ratio, 2 to 5 to 3. Chris, Debbie, and Errol. And they want to know how much money Chris gave to Errol. Well, we now need to know how much each person gets, and then we'll be able to figure out how much Chris gave to Errol and Debbie and all of that. So first we need to know how much money there was originally, because then I can share it in whichever ratio they give me. So the original amount, so how much money? So the total amount of money that they were sharing was your £90 plus 120 plus the £60. So there's actually £270. To find out what one part is, I have £270 that I'm sharing between 2, 5, and 3. So altogether we've got 10. So 270 divided by 10 equals 27. So each part gets 27. Using this, I can then know how much Chris, Debbie, and Errol got. So going to find out how much Chris got, I'm going to times that by 27. So Chris got 27 times 2, which is £54. I could do Debbie, even though I don't really need it. But Errol got 3 times 27. And I got £81. And if you did want to know what Debbie got, you're just going to, again, multiply it by 27. And you get Debbie got £135. So if you look at this last part over here, how much money did Chris give to Errol? Errol over here originally had £60. And now Errol has £81. So how much money did Chris give to Errol? It's whatever the difference is. So to find out how much money Errol now has, I'm just going to take away and see how much more money he made. So that's 81 minus 60, which equals £21. Now this question is really lovely because it shows you both kinds of ratio questions. The times where they tell you to share that amount, and the times where they told you they've shared it and this is the final amount. Okay, so be very careful with those kinds of questions. Okay, question 6, bearings. This is what you need to know about bearings. So bearings always start from north. So the bearing of port B from port A is 147. So let's draw something that represents A and something that represents B over here. And bearings are always from north, N, and north. And you'll see why I drew B a little bit lower. Now it says here, the bearing of port B from port A is 147. So from port A, I'm over here, and I'm going all the way over there to port B, and this is 147 degrees. Now the question wants us to work out the bearing of port A from port B. So let's go to port B first, and we're going to go all clockwise all the way until port A. So they need to know what this green angle is. Now, how are we going to go about doing this? If I knew what this angle was inside, this blue angle, I could figure out what the green one is because the angles around a point make 360. So I need to know what the angle, this blue angle, is over here. Now the two norths are parallel, and there's a rule for that. If you don't know it, just make a note of it. Two parallel lines, the interior angles add up to make 180 degrees. So this angle plus this angle makes 180 degrees. So now, to find this blue angle over here, I'm going to do 180, take away 140, and I get 33 degrees. So this angle inside here is 33 degrees. Now to find the actual bearing which they're looking for, I need to do 360, take away that 33, so I end up with 327 degrees. So that's my answer. A few things about bearing is they always start from, so let's just make a note here, bearings, they start from north, they're always clockwise, and they're a 3-digit number. So if you've got an angle of 327, that's fine, you leave it at 327. If you have an angle of 25 as a bearing, you don't write it as 25, you write it as 025. That's your bearing. Okay, so this is just a side note over there. Question 7. Right, the diagram shows an empty tank in the shape of a cylinder, and it gives you the cylinder. The cylinder has a radius of 15 centimeters and height 43 centimeters. Water flows into the tank at a rate of 0.47 liters per minute. They want to know the number of minutes it takes to completely fill the tank. If you're filling in a tank, what are we talking about? We're talking about volume. And if you weren't sure that we were talking about volume, they mention liters here as well. So liters is also volume. So let's start off with that piece of information. So the volume of a prism, and a cylinder is a prism, is the area of the face times the length. So this is my face over here, which is a circle. So it's the area of this times by my length over there. So the area of a circle is pi r squared times my length. So that's going to be pi times 15 squared times 40. And I end up with 30,394.9. Now notice, my units here are centimeters and centimeters. So my units here are going to be centimeters cubed. But also notice that the question gives it to me in liters, not centimeters cubed, but in liters. So I need to change this into liters. So 1 liter is 1,000 centimeters cubed. So to get it back into liters, I need to divide by 1,000. So if I divide it by 1,000, I end up with 30.39 liters. Okay. Now, calculate the number of minutes it takes to completely fill the tank. So according to this piece of information, you can fill up 0.47 liters in 1 minute. So if you had 30.39 liters, how many minutes would it take you? So we're going to do 30.39 divided by 0.47, which equals 64.67. Now, if I put my final answer as 64.7, even though that's correct, would I get full marks? Not really. Why? Because this last little sentence over here, they want it correct to the nearest minute. So be very careful when you're doing that. So the nearest minute is 65 minutes. So your final answer has to be 65 minutes. If you left it as this, you would just get 3 marks out of 4. So just bear that in mind. Okay, just by looking at how they present the answer over here, I know this is upper bounds and lower bounds. Okay, so let's answer this question. The number x is written to 2 significant figures. The result is 1.9. So here, this 1.9 was in between 2 numbers. Let's put the 1.9 over here. A little cute heart. This 1.9 was in between 1.8 and 2.0 to 2 significant figures. Now, when you're doing upper and lower bounds, it's always halfway in between. Okay, it's plus or minus halfway. So if I look at halfway over here, I have 1.85, and here I've got 1.95. So my error intervals for x are 0.85 and 1.95. Again, remember the question 1 of this exam paper. Question 1 said expand and simplify. This one's also saying expand and simplify, except over here they're just brackets. And we said whenever we've got brackets, what do? We multiply. So we're going to start off with the first 2 brackets, x. X times -2 is -2x. Now we're going to do the same. 7 times x is 7x, so it's positive 7x. 7 times -2 is -14. All of this is times x plus 3. Let's clean this up a bit. -2x plus 7x, positive 5x. So you've got x minus 14 times x plus 3 by x times x squared times this and times that. So x times x squared is x cubed. X times 5x is x squared. X times -14 is -14x. So x squared times 3 is 3x squared, and they're both positive. 5x times 3 is 15x, so plus 15x, and 42. We have an x cubed here. Do we have any more x cubes? No, so let's just put it down. We've got 5x squared, and I get the sign in front of it. That's really important. Plus 3x squared, which is 8x squared. Now let's look at the x's. I've got -14x plus 15x, which gives me positive 1x. I don't need to write the 1, so I'll just write it as positive x. Negative is my final answer. So let me give you a little bit of information about tree diagrams on the side if you're not sure about it. Diagrams basically is a way of showing your data if you've got more than one event happening. So it could be one event is I'm doing my first, then my second event is my second test. Or one event could be I play football, and then the next event could be I play, if I win that, I play basketball or something like that. I've got 2 events happening. Okay? Now, the information that you need to know is the probability. We write down the probabilities over here on the tree diagrams. The probabilities on each branch add up to make 1. So I'm going to write probabilities add up to make 1. That's really important. So all the probabilities over here would add up to, if this was 0.7, then this would be 0.3. If this was 0.6. Second thing is, if I'm going and I'm looking at the probabilities there, I times them together. So if I'm doing this probability and that probability, the word and means times, I times. If I'm going down, now let's get rid of all of that. Shakir has to complete 2 tests. He can either pass or fail each test, okay? the probability that he will pass the first test is 0.87. So this him passing it is 0.87, failing that first test, which is 1 minus 0.87, which is 0.13. If he passes the first test, the probability that he passes the second test is 0.94. Now, using this information, I know I can then figure out the probability of him failing it, which is 1 minus 0.94, which is 0.06. Okay, the probability that he will pass the second test is 0.73. So if he fails his first test, the probability that he passes it is 0.73, which again means that we can figure out the probability of him failing it. So it's 1 minus 0.73. So we've got 0. Work out the probability that Shekhar passes at one of the tests, at least one of the tests. Now there's two ways of doing it. You can do it the long way, or you can do the short way. So the long way is to get all the probabilities and add them up together. So if he passes at least one of the tests, he'll either pass the first one, 0.94, so that's 0.8178, or he could pass the first one and fail the second one, so that's 0.87 times 0.06, so you get 0.0522. Or he could fail the first one and then pass the second one, because then he's got at least one of the tests. So that's 0.13 times 0.73 at 0.0949. Passing at least one of the tests. I'm going down now, so I'm going to add this plus this plus this. So the probability he passes at least one would be 0.8178 plus 0.0522 plus 0.0949, right? So if I add them, I get 0.9649. That's the long way. The short way is, so if I wanted to find out the probability that he passes at least one of the tests, is all of them minus the probability that he has two fails, right? So the probability he passes at least one of the tests is just 1, as the probability that he fails both of them. You get 0.9649. Okay, question 11. You've got these weird signs over here, the proportionality. So if I were you, I'll just pretend it's an equal sign. So let's pretend that's y equals x squared. The y equals x squared graph, U-shape. Y equals x graph looks like a line, a diagonal line. Y equals 1 over x is a weird one, like this and like that. It doesn't touch 0 basically, because x, you can't divide that last one. I don't even know if it's going to be the last one. So y equals x squared. Which one of them looks like a U shape? This one over here, grade D. So that is graph. Y equals x. Yep, looks like that one. So y is proportional to x is 1 over x is that weird one over there. Graph B, because it doesn't touch 0, because x cannot equal 0 at the bottom. And then the last one is that one. So you end up with that. So question 12 says that you've got, it gives you information about the points. A is the coordinates of 7 and 3. B is a coordinate negative 321. C is the coordinate of 1523. Then it says that M is the midpoint of AB. The word midpoint, again, is a very key word. There's a formula for it. So if I'm looking at something in the middle, if I had the number 2 and the number 4, what number is in the middle? We know that's going to be a 3, right? How do we get it? You just do 2 plus 4 divided by 2 to get 3. Okay, so 2 plus 4, 6 divided by 2, you get 3, which is basically the average. The midpoint is just the average of the coordinates. Let's write that over here. Midpoint. So M is the midpoint of AB. This is my A. This is my B. So M equals my x's, which is 7 plus minus 3, 7 plus negative 3 over 2, and my y's, which is 3 and 21, so 13 plus 21 over 2. So that gives me 2 and 17. So we've got our M. So N is the midpoint of BC. So there's my B, there's my C. And we're going to do the same exact thing. So N equals, again, open up my brackets, and we're looking at the averages of our x's, -3 plus 15, -3 plus 15 over 2. And for my y's, 21 plus 23 over 2. So it gives me 6 and 22. Now, even if you can get 6 and 22 and 2 and 17 straight away, still write it out like this, because if you make a mistake that we all do, like a silly mistake, you will get a mark for this, even if you wrote it as a different number. Okay? Now, let's put a bubble around this one because you need this formula. So next part of the question says this: work out the distance between, if you had M here and N there, for example, and you want to know this distance, you can make it into a triangle like this, and this is your hypotenuse, which is your distance. Okay, so the formula for the distance, and you know the hypotenuse is this squared plus that. The formula for your distance is the square root of something squared plus the other one squared. Okay, so one of them is your y's, one of them is your x's. So it's the difference of your x's, so x2 minus x1 and y2 minus y1. This is all you really need to know, this formula over here. Right, now let's work out the distance between M and N. Right, distance equals the square root of my x's, subtract the difference of my x's, so 2 minus 6 all squared plus the difference of my y's squared, so 17 minus 22. So it says give your answer correct to 1 decimal place. So I checked 6.403 to 1 decimal place, it's 6.4. Okay, now next one. Now prove algebraically that 0.0723 can be written as that. These dots at the top means that they're recurring. They go on forever and ever and ever and ever and ever. Okay? Now, side note over here, for your other recurring decimal questions, side note. Now, here, if the dots are just on the 7 and the 3, this is 0.0, then 723, 723, 723. So this 0 is not recurring. This is the type that we're dealing with now. The top one is a little bit easier, but they're both actually not too difficult. We want to write it out in the long version and take them away so that we can get rid of all these recurring decimals. First, let's write it as x equals and write the long version. So that's 0.0723, 723, 723, etc. Because this is not recurring, I want to get that 0 to be on that side, so I'm going to times it by 10. And then I also want to get the whole entire thing onto the other side. So I'm going to times it by 1, 2, 3, 4. So times by 10,000. So let's do that. Times this by 10, so I get 10x equals 0.723, 723, 23, etc. Now I want to get the whole thing onto the other side, so I'm going to multiply it by 10,000. So if I times this by 10,000, 10,000 x, everything's going to move, the 0, the 7, the 2, and the 3. So 0.0723, 723, 723, etc. Now notice, after my decimal points, they're all 723s. So when I subtract them, when I do this, take away that, these will all give me 0. And then take away 0, which is 723, equals 10,000, take away 10, 9,990x. Now I want to get x on its own, so what am I going to do? I'm going to divide by 9,990 on both sides. So x equals 723 over 9,990. But the question wants me to write it out as 241 divided by 330. So if I look at the denominator, it's easier to look there. I divide top and bottom by 3. So divide by 3, 341 over 3,330. Question 14. Y is proportional to x squared. So we write it as this: y, that fish sign, x squared. That fish sign is the same as equals k. So this could also be written as y equals k times x squared. Now let's look at the next sentence. Y equals 3 equals k, I don't have k, times 0.5 squared. So k equals 3 divided by 0.5 squared, k equals 12. Now that I have this k, I'm just going to replace it with this k, and then I'm going to forget about everything else. So I end up with y 12x squared. Once I get to this, I forget about all my previous steps, bubble around this, and I forget about everything else because this is all I need. X is inversely x, but it's not proportional, it's inversely 1 over w. And this is written as x equals k divided by w. I'm done with this line. Let's look at the next one. X I'm going to put 2 equals k over w. My w is 2. So k equals 2 times 2, which is 4. So I'm going to replace this k with k equals 4. So x equals 4 over w. I'm going to do the same thing. I'm going to put a bubble around this because that's all I care about now. And I'm going to forget everything I did before that. Now let's read the actual question. It says, find the value of y when w equals 2. Okay, so if I look at both of these equations, I've only got a w over here in the second one. So I'm just going to do that. So equals 4 divided by, instead of w, I'm going to put 2. So x equals 2. But what does the question want? They want the y. So now I'm going to look at this one. Let's write it over here. Y equals 12. So y equals 12 times 2 squared, 48. And that, my friends, is the answer. Question 15, it literally says histogram over here. Now, with histograms, always have density over here. Notice they've got it over there. And at the bottom, they've got the class width. And the class width is like the time, how wide this is. Okay? And there's 2 pieces of information that you need to know about histograms. First one is to find your frequency density. You do the frequency divided by the class width. So whatever the frequency here is 10, is 4. So you do 10 divided by 4. That will give you the frequency density. Now, the other piece of information that you want to know is that the area of these bars is your frequency. All these areas are rectangles, right? So if I do length times width, and my length is frequency density times the class width, I get the frequency. The area inside is your frequency. Okay? Now let's look at this question. Sometimes using the information of just area frequency is easier, but in this particular question, the way it's cut up isn't very nice. So we want to complete the histogram and we want to complete the table. Let's use one of them. If I wanted to know where the frequency density, find the frequency density, that's the frequency over the class width. So here for the 12 and 16, which is this section over here, my frequency density is my frequency, which is 10, divided by the class width, which is 4, equals 2.5. So over here, this part over here for my frequency density is 2.5. Now that's going to help me understand the scaling. It could be 1, 2, 2.5, then it goes to 3, 4, 5. So do you see how we use that piece of information? Now we want to complete the histogram. So let's work out the frequency densities for each one of them. So the frequency density for 15, 6, 16, 17, 19. So the class width over here, so I'm doing 15 divided by 3. So this is 5. This here is 2.5. For 9, The class width over here is 3, so the frequency density is going to be 9 divided by 3, which is 3. Here, the class width is 5, so the frequency density will be 7 divided by 5, which is 1.4. Let's fill this in. So this is already done, 12 to 16, 19 to 21, and it goes up in 2s. So 19, 20, 21 would be somewhere over there. Okay, so we're looking at here 19 to 21 is somewhere over there, and the frequency density goes up to 3. So we've done this one, and these two are already done. 21 to 26 is 1.4, so 21 to 1.4, this is 1.5, so this is going to be 1.4. So that is this one over there. Now let's fill in the frequency for the first one. 4, 10 to 12. 10 to 12, let's do that in, so 1.5 times 2, so my frequency is 3. So I have now completed. Okay, use the histogram to complete the table. We've done that. Use the table to complete the histogram. We've done that as well. Now let's look at the next question. Gives information about the time taken by 43 students to run a different race. Work out the estimate for the median of the times taken by these 43 students. Right, so the median is the middle number, right? So we've got 43 students, so that's 43 divided by 2, which is the 21.5th student. Okay, so it says that ABCD is a trapezium. Okay, got that. AD is parallel to BC. That might come in handy, especially when we're talking about parallel lines. We're thinking about those angles, the Z, F, and interior angles. Calculate the area of triangle BCD. Where's BCD? BCD. So we want to know the area of it. If it was a right angle triangle, we could just use base times height divided by 2. Okay, but it's not. It's a non-right angle. So the formula for that is your area equals a half AB sine C. Now, just so that you know what A, B, and C are, if I have a triangle over here, you've got two sides next to each other and an angle in the middle. That is your C, okay? So if you've got this length, that length, and C, you literally just have to put it in there, okay? Area of a triangle, which is a half AB sine C, is usually part B of a cosine rule question. So that's a good trick to have up your sleeve. Now, what information do we need? So we know that B here is 15.3, but we need to know what A and C are. How are we going to find them? Should we find the angle first? Should we find the side A, or should we find the angle first? It doesn't really make a difference. We have to find both of them anyway. So if we try to find the angle, let's just do that because we did bearing. And remember when we said when we've got parallel lines, two parallel lines, what do we know about the angles in the middle? The interior angles make up 180 degrees. So to find out this angle over here, I'm doing 180 minus 112, which gives me 68. So this full angle over here is 68 degrees. But we don't want that. We just want that pink one over here. We want this one. So how can we find that? Well, we've got a triangle, don't we? In that triangle, all three angles make 180. So we can find out what this angle is over here. So to find out that angle, I do 180 minus 112 plus 42. So that angle becomes 26, which means my pink Q angle is 42 degrees. So now I know that C is 42 degrees. So I've got B, C. Now I just need A. Okay, let's do A in black. So I need to know this side over here. I need to know this side over here. So notice I've got a side and an opposite angle. I need this side and I've got the opposite angle. So that's a sine rule. Now the sine rule is A over sine A
equals b over sine b. And it doesn't really matter what a is, which one is b, which was p, q, r. It doesn't matter. All you need to know is the side over the opposite angle. So the side over sine of the opposite angle. The other side over sine of the opposite angle. So a is going to be this. So let's call that a over sine a. So it's sine 112 equals b, which is this side over here, 7.9 over the opposite angle, which is sine 42. So a, I need to equals 7.9 over sine 42 times sine 112. And if I put it on my calculator, a equals 10.95. Now, if you want it to be really accurate, keep that 10.95 on your calculator and then substitute it straight away. So a equals 10.95, blah, blah, blah. Now, I put it into my calculator, and basically all I have to do is substitute now to get the area. So area equals 1/2 a, which is 10.95, times 15.3 times sine c, which is sine 42 degrees. Now, if I put this on my calculator, I get 56.05, blah, 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 blah. Okay. Now, the question says round it to 1 decimal place. So that is equal to 56.1 centimeters squared. Okay. If you were more accurate and you did 7.9 divided by sine 42 and then multiplied it by sine 112, you get 10.94, blah, 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 blah. And then you substitute it straight away into the equation. So times b, which is 15.3, times sine 42 times 0.5, you actually end up with 56.03, blah, blah, blah. So to 1 decimal place, your area equals 56.
Okay, show that this has a solution between x equals 1 and x equals 2. Okay, first let's quickly look at a solution. If you've got a graph like this, and if you've got a graph that looks something like this, and there's a solution over here, that means it cuts the x-axis at that point. So wherever it cuts the x-axis, these are all solutions. That's why with quadratics you have x equals a number and another number, because quadratics are cut at 2 points. Now, if it's got a solution between 1 and 2, so let's assume that here is 1, here is 2. If you've got a solution between 1 and 2, it means that your signs will be different because it cuts through there. That's where your solution is. So here your sign will be negative and here your sign will be positive. Yeah, even if it's on this side, if there's a solution over here, your sign would be negative here and your y would be positive over there. So if I want to show that there's a solution between x equals 1 and x equals 2, I'm just going to substitute both of them in, and if there's a change of sign, then there's a solution. Okay, so when x equals 1, I've got 1 cubed plus 2 times 1 minus 6, and that gives me negative 3. When x equals 2, I have 2 cubed plus 2 times 3 minus 6, and that gives me 6. So there's a change of sign, negative and positive. So there's a change of sign. Therefore, it has a solution between x equals 1 and x equals 2. Now, show that the equation can be rearranged to give this. So notice that there's an x here and an x here, and the 6 is on the other side. So first of all, let's bring the 6 over. So I have x cubed plus 2x equals, bring the minus 6 over there, it becomes positive. So equals 6. Now, I've got x cubed and 2x, so I can then factorize the x out. So take the x out, and I end up with x squared plus 2 equals 6. So this is x times that. The opposite of times is divide, so I'm going to take that over and divide it on that side. So x equals 6 divided by x squared plus 2. Done. Okay, starting with x equals 0, These are just basically substitution, okay? So use the iteration formula twice. So we use it twice to find an estimate for the solution of this. Okay, so if x equals 0, so we're going to put 0 there. So x 0 plus 1 is 1. 6 over x 0 squared plus 2. So now let's substitute. So x1 equals 6 over 1.45 squared plus 2. Now the iteration formula, you're just basically using the previous answer each time, 0.4625. So we did it once, let's do it again for x2. So x2, we're going to use the previous answer, is 6 over 1.4625 squared plus 2. So x2, 1.446.
Let's look at this question. We have ABCD is a quadrilateral, four-sided shape, okay? E, F, G, and H are midpoints of AB, BC, CD, DA. Now this question is obviously about vectors because I can see vectors left, right, and center, which means the direction matters, okay? AH equals A. So from A to H, the direction is going this way, and this is A. Because it's the midpoint, if AH is A, then HD is also going to be A. Okay? Now, AE equals B. So AE, so it's going in that direction over there. And that is B. So if that is B, then EB is also going to be B. Done. DG equals C. So DG, which is this one over here in that direction, is C, which means that GC is also going to be C. Now, it says prove using vectors that EFGH, let's get that in green, EFGH is a parallelogram. So where's EFGH? EFGH. Let's connect them. These are parallelograms. If I work out each one of these sides and the vectors are the same, they're equal, then it's a parallelogram, okay? Because if you remember in straight line graphs, parallel lines have the same gradients, okay? So if they're equal, that means their gradients are the same. That means these two sides are parallel. EH and FG will be parallel to each other. And EF and GH, if those two are equal, that means they have the same gradient, which means that they're equal to each other, okay? So just remember, because you're going to need, this information is good for straight line graphs. If they say parallel lines, that means your gradient is the same, okay? Anyways, so basically we just want to prove that they're equal. Now, what you need to know about vectors, just as a side note, if you're going in the same direction, you're keeping the same sign. If you're going the opposite direction, you change the sign. If you remember that, life with vectors is just gorgeous. So let's see what we've got over here. So prove using vectors a parallelogram. Let's start with EH and FG. So the vector for EH, we're at E and we want to get to H. So I'm going in the opposite direction. So it's going to be minus B. And then to get to H, I'm going in the same direction. So it's plus A. Done. Now let's look at FG. So FG. Now I want to get from F to G, right? So I need to know what this vector is over here. I don't know what that is. So let's do that in a different color. We want to know what that is, right? So it's BC because they said it's BC over there. Let's figure out what BC is. So I'm at B and I want to get to C. I've only got one choice to go the long way. Okay, so let's do BC and write it over here. BC equals, I'm going in the opposite direction, B and B, so that's minus 2B. I'm going in the same direction this way, so that is positive 2A. And then I'm going D to C in the same direction, so it's plus 2C. So I know BC. If I know BC, I can figure out FC, which is just half of that. So half of that means that this FC is just going to be negative B plus A plus C. And then BF is also the same. BF, best friends, huh? Minus B plus A plus C. Okay? Now that I've got the information, let's get back to business. FG. Where's FG? Where's G? Where's G? There we are. FG. So this vector is going that way, by the way. So FG, we're at F and we're going to G. So we're going this way in the same direction. So that is minus B plus A plus C. And then I'm going to G in the opposite direction. So it's minus C. Now plus and minus C cancel out. So FG equals negative B plus A. So I write here. So EH is equal to FG. So I've proven that these two are parallel to each other. Now let's do the other side. Let's pick another color. Let's look at EF and HG. I'm going to start with HG. To get from H to G, I'm going in the same direction, so it's positive A. In the same direction, so it's positive C. Done. Now I want to get EF. So EF. So I'm going to go in the same direction, so it's positive B. And I'm going to go in the same direction again, so it's the same sign, so it's minus B plus A plus C. Now B and minus B cancel out, so EF equals A plus C. So HG is equal to EF, therefore I'm just going to copy this line. FGH is a parallelogram.
Right, the functions f and g are such that this is f of x, so the function of x, the function of g is that. Find g f of minus 3. Let's do f of minus 3 first. Let's just break it down into f of minus 3 first. So f of minus 3 means that all my x's are going to change into negative 3. So open brackets, 2, I write 2. Instead of x, I write minus 3 plus 3 all squared. So I've got 2 times minus 3, negative 6 plus 3 all squared, which gives me 9. So f of minus 3 is the same as 9. So this is the same as saying g of 9. Let's see my function of g. It's this one over here. I'm going to replace it with 9. So that's going to be 2 times 9 minus 1, 18 minus 1, which equals 17. Find g minus 1 of x. This is the inverse. So here's my original. G x equals 2x minus 1. What we want to do is we want to do the opposite of everything that's happening. So let's just pretend that this is y equals 2x plus 1, 2x minus 1, and then rearrange that. So that becomes plus 1, so that's y plus 1 equals 2 divided by 2, so divided by 2. Can I do that?
Okay, be honest. Your first thoughts when you see this question, it looks horrible. Horrible. But that doesn't matter to us. What you want to do is you want to break this down to the core skill of the question. If I look at this question, what is this question? It's a fractions question. Then I look at what I can do with it. I wouldn't attempt to do this whole question. I'll just do one step and each step will unravel the next part. Okay, you don't want to be overwhelming yourself. So I can see here that there's a divide sign. When I come to divide fractions, I change this to times and I flip this over. Okay, so that's the first step that we're going to do. Let's copy this down. X plus 4. And then we're going to change the divide sign into times and flip this over. So I end up with 2x plus 3 on top and 2x squared minus 6x minus 56. If I look at this question, typically these kinds of questions, if you end up with a quadratic at the bottom, this quadratic over here can be split up into 2 brackets. And because they're all being multiplied, I can cancel stuff out. So let's do that on the side. They're all even numbers, so I can factorize out the 2. Take the 2 out, I end up with x squared minus 3x minus 28. I still have the 2 on the outside, but here I've got a quadratic, so I open up my 2 brackets. And I put x here and then x here. 2 numbers that multiply to make negative 28 and add to make negative 33. Okay, that would be negative 7 and positive 4, because negative 7 times 4 is negative 28. Negative 7 plus 4 is negative 3. So now that I've got this, I'm just going to replace it over here in this one. So let's copy it again and replace it. So now in the denominator, I'm going to write 2x minus 7, x plus 4 in brackets, and then close my big brackets. Now notice, when I get to this stage, you'll see that there's an x plus 4 at the top, which can cancel with the x plus 4 at the bottom. And it's very important that you know, because you're multiplying, you can cancel. But if that multiplying sign was a plus or a minus, which they wouldn't do in a question like this, you won't be able to cancel. So because it's times, you can cancel the x plus 4 from here and the x plus 4 over from here. And you'll see how simple it looks now. I've got 2x on top plus 3 over 2 brackets x minus 7 at the bottom. I actually don't need that bracket, so let's get rid of it. Now that I'm at this stage, what is the core skill or the key skill here? It's a fraction again, because obviously they're fractions and they're being added. So what do I know about adding and subtracting fractions? That my denominators need to be the same. So let's make this 3x minus 21 in a bracket like this one. So factorize it. So I end up with, if I take 3 on the outside, I have x minus 7 on the inside and 14 on top, plus, just copy that down, 2x plus 3 over 2 brackets x minus 7. So now we want our denominators to be the same. So if I look over here, I've got 3 and 2. How can I make them the same? If I multiply this 3 by 2, I get 2 times 3, which is 6. And if I multiply this side by 3, I do 3 times 2, which is 6. And whatever I do to the bottom, I do to the top. So multiply the top by 2, multiply the top over here by 3. Let's carry on. So at the top, I've got 2 times 14, which is 28. And at the bottom, I've got 2 times 3, which is 6. And in brackets, I've got x minus 7. Plus, so I put plus. Let's start off with the denominator here. 2 times 3 is 6. X minus 7. Now be very careful when you're doing this numerator, because it's not just times 2x or just times 3. It's times 2x plus 3. I have to remember to put it in brackets so that I'm multiplying each term by 3. Okay? So I do 2x times 3, which is 6x. 3 times 3, which is 9. Now, are my denominators the same? Yes, they are. So let's rewrite that. At the bottom, I have 6 brackets x minus 7. And at the top, I've got 28 plus 6x plus 9. I'm just going to simplify a little bit more. 28 plus 9 will give me 37. So that is 6x plus 37. Now, the question wants it in the form of ax plus b over cx plus d. So I'm just going to expand the 6x minus 7 so it looks just like that, because I want this form over here. So if I expand it, I end up with 6x minus 42. Now, are they the same? Yes. Okay, this is a lovely Venn diagram question. So Vicky has a collection of medals. The Venn diagram gives information about the number of medals in her collection. So A is English medal, so this is English. B is gold, so this side is gold. Then it says that Vicky is going to take at random a medal from her collection. Given that, this isn't just any word, this is a given that, okay? This is really important in probabilities, Venn diagrams and all of that. So given that the medal is gold, the probability that the medal in English is 2 over 11, okay? If we're talking about given that, we're not looking at the probability of everything. We're looking at the probability of, given that she gets gold, what's the probability she gets English as well, okay? So the formula for it, I'm going to write on the side over here. So just keep that over there. Given that the probability the medal is gold is this whole entire section over here, okay? So it's all out of it being gold, which is x plus 5x minus 3. The probability for her medal being English, given that she's gold, is just this section over there. This is the English, given that she's got a gold. So it's x out of the gold. Equals 2 over 11. Let's simplify first and then cross multiply. So x on top over x times x plus 5x, which is 6x minus 3, equals 2 over 11. Now cross multiply. So we've got 11x equals 2 times 6 minus 3. Now, just like the previous question, be very careful when you're multiplying and you've got two terms, because if you look over here, you've got 6x and -3. So let's put them in brackets so we don't make that mistake. So it's 2 times 6x minus 3. That's 11x equals, expand your bracket, 12x minus 6. Now we're going to rearrange to find x. Bring 11x over to that side, becomes minus. And bring the minus 6 over there, becomes plus. So we end up with 12x minus 11x, which is 1x equals 6. Now that I know what x is equal to, let's see what the question actually wants. The question says, work out the number of medals in Vicky's collection. So let's see. The number of medals in her collection is all of this is the 7x minus 11 plus the x plus the 5x minus 3 and a 34. Now that we know what x is, we can then find out the total number of medals in her collection. So let's replace each x with 6 to find out how much she's got, how many medals she's got. So this will be 7 times 6 minus 11, which will give me 31. Here x equals 6. Here we've got 5 times 6 minus 3, which equals 27. And we've got our 34 over there. So the total number of medals is 31 plus 6 plus 27 plus 34, which equals 98 medals.